Hey everyone, say that you've got a function on an interval from a to b, and you know the derivative of that function is equal to 0 at every single point. I'm going to use the mean value theorem to prove to you that that function must be equal to a constant. And let's figure it out. So the statement that I just said was you have a function defined on some open interval from a to b. You know that for every x value in between that interval, you've got f prime, well, first of all, existing, and second of all, equal to 0. And I assert that this means that f of x must be equal to a constant. So what does this have to do with the mean value theorem? How can we prove this statement? So here's the way that we can do it, and it's actually pretty cool. So what you can do is you can just pick any 2 points you want in the interval from a to b. Let's call them x1 and x2. And one of them will be less than the other. Let's call x1, less than x2. And make sure they're actually different points, so they're not equal. And then I'm going to apply the mean value theorem to the interval from x1 to x2. And so we've got a function that's differentiable from x1 to x2. If you're differentiable, then you're continuous. So it satisfies the hypotheses of the mean value theorem. When I say hypotheses, I just mean assumptions. And so if I apply the mean value theorem to this interval from x1 to x2, what I'm going to get is that there must exist a point C in between x1 and x2 with the property that if I look at f of x2 minus f of x1, it's the difference of f on the x values, the endpoints, that has to be equal to f prime at the point C times x2 minus x1. That's just the statement of the mean value theorem, isn't it? But just with a and b replaced by x1 and x2. And since I know my assumption is that the derivative is equal to 0 for every point that's between a and b, that certainly counts for the point C, this right-hand side must be equal to 0. So actually this tells me that f of x2 has to be equal to f of x1. So the y value for those 2 points has to be the same. But this was completely arbitrary. You can pick those points at random. You can pick those points however you like. And this conclusion will always be true. So this actually tells you that every y value for every x value in that interval is the same. And isn't that the same thing as just saying that the y values are constant? So that's kind of a nice application, an early application of the mean value theorem. Just because the derivative is 0 at a particular point doesn't mean the function is constant. But if that derivative is equal to 0 on a full interval from a to b, then it is true that your function is a constant.